It's part 2 of part 1. We have discussed part 1 of this lecture. Now it's a second. This is the second part. Here we have this is question based on trigonometric function. Question is saying find the value of a cos minus this much. We know that this is too much. This degree is too much. So how to calculate like that question? This is very simple. Just you know that 2 pi radian is a 1 revolution and 360 degree is a 1 revolution. So how much revolution is it? So it is a 5 revolution. 5 and then 5. Okay, 5 multiple 2 pi. 5 revolution and then 300. We will multiply by this. So we will get this much degree. This much degree. 5 revolution multiple 300 degree. Or you can multiply 5 by 2 pi. Both are same. So here you are saying that this much rotation, 5 rotation, it is in degree. Now we know that after this 5 rotation we are more, which is 90 degree. It is at perpendicular. So we know that cos 90 is what? 0. Sin 90 is 1. So that is how this process will come. Yeah, your process can be different, but answers should be same. There should be logic behind your process. Now I am moving. Here we have second question. If cos x is this much, which is given minus 3 upon 5, x lies in the third quadrant. It is already telling you that x lies in the third quadrant. I think tan code. So find the values of other trigonometric functions. We know that this is the first trigonometric function, and apart from this there are more 5, and x lies in the third quadrant. So first of all, we know that this is given already. So tell me what is a ratio of cosec x. So ratio is what? Base upon hypotenuse. Base is minus 3 and hypotenuse is 5. So sec would be what? Sec is the reciprocal of this. Just opposite. Denominator will go upper and then numerator will come downward. This is second trigonometric function. We found this by this. Now we don't know what is the value of a perpendicular. We don't know. So for this we will find it just by using Pythagoras theorem. We know sine square x plus cos square x is equal to 1. We know sum of this and this would be 1. So can we say that sine square x will be equal to 1 minus cos square x? Of course. We can also say that cos square x will give us 1 minus sine square x. This is coming from this. Clear? Now here we know that this is just here we will put a value of a cos. We will substitute value of this over here. Then after simplifying it, we will get sine square x, sine x. So after simplifying it, we are getting 16 upon 25. Okay, so both are perfect square of. This is a perfect square of 4 and this is a perfect square of 5. Now here, since x lies in the third quadrant, then sin x will be negative. Why? Because it is telling you that x lies means theta is in third quadrant, but we know that sin cos is in second quadrant, then it will be positive. But here it is this sign is coming in third quadrant, then we know that tan quad will be positive, but sine will be negative. So here, rather than applying positive, we will apply negative. So final answer would be minus 4 plus x. Okay, this minus came because of a quadrant. quadrant, it is saying that this theta, this value of this theta is in third quadrant. Now then here we have found this trigonometric function. Now we also found this and now our reciprocal of this would be what? Cosec x, just opposite of this, minus 5 upon 4. Now we left how much? 2 more, which is tan quad. Okay, tan quad. For this I think we should have p, value of p. So here we know that we have what? Value of a sine and value of a cos we have. So sine x is what? Sine x where 4 upon 5, and this is how much? Cos here minus 4 upon 4, minus 4 upon 4. Hold on, here sine we have 4 upon 5, so cos we have cos 3 minus 3 upon 4. So still, so now here we have what? A tan x. Here x is in third quadrant. We know that tan and cot are in third quadrant, and this will be positive. So here we are not using minus, we are using plus, because this tan is in third quadrant and x is theta is in third quadrant. So if x is in third quadrant, so tan cot will be positive. In second quadrant, sine cos will be positive. In first quadrant, all trigonometric functions will be positive. Okay, not clear. So reciprocal of this would be what? Cot x, 3 upon 4, just opposite of this. Now this is done. Now we are going to see sign of trigonometric functions. Quadrant. Sign of trigonometric functions. Here we have what? Sin x is equal to b. Value of this is equal to this, and sin cosec x is equal to a. Okay, this value of this is this much, and value of this is this much. Here what are we observing here? We are observing that just opposite of this is this same, but this is a negative and this is a positive. This is x is a positive, but this angle is a negative. This is what we are observing in this case. Now we know that this b and this a, here b is a y, this b is a y, so y is a minus and a is a what? This x is a positive. So a comma minus b, a comma minus b. We know that the a is a cos and b is a sine. A is a cos, b is a sine. So here sine would be negative and a would be cos. This is a positive. Let's visualize it more. Here first quadrant a comma b, first quadrant a comma b is this in first quadrant. But a comma b, here you see carefully here, see a comma b, which means all these are with positive, isn't it? But when it comes to here, then what will happen? This a will become minus and this b will become positive. Here in second quadrant, this a minus and b plus. In third quadrant, what will happen? A minus and b also minus, b also minus. And in fourth quadrant, only this b minus and x would be plus. Here you can see x would be plus and y is a minus. All these are, we are crystal clear about this. A is a cos and b is a sine. Clear? All these are cos and all these are sine. With the help of this, we can also understand further yet what this is. All these are positive, so all the trigonometric function in this quadrant will be positive. But in this case, in this quadrant, only sine and cos will be here. Sine is what? Sine is what? Positive. So it is telling you that here sine x is what? Positive and cos is also positive. Sine x is positive, but here cos x minus. This is what sine. So a is a what a sine. So a is where this is a sine. This is a sine. B. A comma B. Okay. Now next, this is coordinate. Okay, this is coordinate, and here it would be negative negative. We know. In this case, try to understand. We are saying that in first quadrant side would be positive cosec. In first quadrant we are saying all this would be positive. This is the main for you to understand the sign of a trigonometric function. It is telling that in first quadrant all trigonometric function will be positive, but as we will come in second quadrant, then only sine and cos will be positive. As you will come in third quadrant, then tan and cot will be positive. As you will come in fourth quadrant, then cosec and sec will no cos and sec would be positive. Cos and sec would be positive. Cos and sec. But in second, sine and cosec. Sine and cosec. Sine and cosec, not sine cos. Here, try to understand here. Here we have in this second quadrant. In the second quadrant, this sine is positive. So reciprocal of this would be also positive. Sine reciprocal of a sine is what? Cosec. So that's why here we are saying reciprocal. This is a sine. Sine x is what? Positive. So reciprocal of this would be positive. Okay. Here in third quadrant, both are negative. Both are negative. So we know that this upon this, sine upon cos is what? 10. We know 10. So tan would be positive, and reciprocal of this tan would be also positive. Now next we have in fourth quadrant. In this what we have negative, and then positive. So sine is negative and cos is this. So cos and reciprocal of this cos would be positive. Here you can see cos and reciprocal of this is positive. So we got all this from this. Here we are taking this a coordinate. A is we are considering A as a sine and B as a cos. Okay, cos. So here we have this A and this A and this B. This A and this B. Okay? This B is a sine, this B is a cos, and this A is a sine. That is what we are saying. When this will come here, okay, are you crystal clear about it? If remember, in one first quadrant all trigonometric functions are positive, but in second quadrant only sine. So reciprocal of a sine is would be also positive, sine cosec. In third quadrant, tan, because all sine plus are positive. So tan is equal to sine upon cosine. The tan and reciprocal of this cotangent will be what? Positive. And in fourth quadrant, cos is positive. Cos. This cos is positive, which means this positive. It is the opposite, that's why. Okay, so cos and reciprocal of this will be positive. We are crystal clear about this trigonometric function, sine of a trigonometric function. Now we have some question based on this. Example, find value. Hold on. Example, find value of a sine 22 upon 3. 22 upon 3 is a negative or positive. is a negative. Just we have to tell, that this given thing is positive or negative. So we know that to find the sign, we will have to say that the theta is where is the position of a theta in the quadrant in the circle on Cartesian plan. So 22 upon 3, and this is x, and let's see, we know that this is equal to this 7.33, and it is a what, this is a degree, this is a degree. Now we are crystal clear that this is a less than 90. Any number which is less than 90, all those will be positive. But any number which is greater than 90, then only sine and cosec will be positive. Any number which is greater than 80 but less than 220, in that case only tangent and cosine will be positive. Any number which is greater than 270 and less than 360, then in that case only cos and cosine and secant will be positive. And except this, all those left functions, trigonometric function, will be negative. Clear? Here we have this degree which is less than 90 degree. So here this is the sine. So sine this much a degree, it is what? Positive. Because it is this is in first quadrant, that's why it is positive. So here theta, if it is greater than theta but less than 90, then this would be positive. It is in first quadrant, the value of is positive. This is clear. We answered logically, with reason we answered. Now next question we have a value of the sine this much, 10 upon 3. Just a decimal of this would, this is fraction as you know, it will give us a decimal. So no 3 5s are 15, 3 6s are 18. Yes, this is how much? 60 degree, and this is 3 4s are 4 point something. So 6, so which, okay, 6 plus, here we can see sum of this and this. In that case, 6 and 4 point something. Okay, then here we can see it is a positive, it is also positive. So of course this plus this, so we can say all these are positive. So this is in fourth quadrant. How is in fourth quadrant? 18 upon 3 and 13 upon 3 is in third quadrant. This is a negative and cos is also negative. I think after simplifying it, domain and range of trigonometric functions. Here we have this much. This x values will be domain and y values will be range. Remember, this x values will be domain and this y will be range. Whenever we say range, so range, we are saying that range is the output. Here x would be real number, that is what we are saying. And range would be what? Range would be from -1 till the 1. We are talking about a sign. Okay, we are talking about sign. Are you understanding? We are talking about sine. So if we are talking about sine, then here our range would be from, we will include minus 1, and between this number minus 1 and 1, what will come? All the rational numbers will come, including 0. And we are taking minus 1 as well 1. And same here cos, with cos also. But when it will come to 10, then here we know that this is an integer. X would be integer. But range would be infinite. Same with the cot. R minus n pi, and then n would be integer. We will see this later. Here R is what? A real number. Your y will be real. Infinity, it can be infinity, because the cot tan also give us what? Infinity. We have a sec here. This and minus and this. We will see it later. We have this question based on this dominant range. Find the range of a function this. Fx is equal to sin x minus 1. We know that the range of a sin x is how much? Sin x range is what? Of a sin x is what? Minus 1 comma 1. So first of all we will put minus 1. So minus 1, this meaning of this is this, including minus 1 till the 1, including this also. So minus 1, and then 1 minus 1. What are giving? Sin x is value of this is what? Minus 1, minus 2, then 1 minus 1, 0. We are getting minus 2 comma 0. So range of function is what? Minus 2 comma 0. This is what is a range. We are including also minus 2 as well as 0. Question: find the range of a function. This. We know that cos x also is minus 1 comma 1, including both. So first of all we will put minus 1 over here, then it will give us 2 minus 2, then 0, minus 1, hold on, yeah, but first of all 0, minus 1, then 1, minus 1, minus 1. Here we had what? Sin x, but in this case we have cos a square. A square is coming. That's why minus 1 raised to power 2 would be 1. So 1 minus 1 will give us 0. So that's why here is this is what? 0, because of this is a square. And when we put 1 here, 1. So again 1 minus 1 will be 0. So here 0 minus 1, it will be minus 1, and this will be 0. So range of function of this is minus 1 comma 0. You can see what is it. Sine in quadrant 1, it increases 0 to 1. All this is very important to visualize a circle on Cartesian point in the context of a trigonometric function. Here it is saying when sine will start from 0, then it will increase from 0 to 1. But in quadrant 2 it will decrease. and then in quadrant third it will more decrease, it will more decrease. Then in fourth quadrant what will happen, it will increase, it will increase in fourth quadrant. So what is happening, sign in first quadrant it is increasing, but in second quadrant it is decreasing, in third quadrant it is more decreasing, but in fourth quadrant it is increasing. Same in cos, it is just opposite, it first of all it decrease, then it again in second quadrant it will decrease more, then in third quadrant it will increase, then in fourth quadrant it will increase more. First it is in both in first to second, in first and second quadrant cos is increasing, cos is decreasing, but in third and fourth quadrant cos is decreasing, as you can see. Yeah, isn't it? It is to visualize. Here tan it starts from 0, tan starts from 0 but goes till the infinity in first quadrant, and in second quadrant it is just opposite in minus 5, it starts from infinity till the 0 in second quadrant, and in third quadrant it increase, here it is also increasing, here it also increase from 0 to infinity, and in third tan is also increasing so tan in fourth quadrant it is increasing, it is increasing. Got? So decrease because it is just a reciprocal of this, so work of this would be opposite of this, it is increasing infinity to 0, of course decreasing 0 to minus 1, 0 to minus 1, yes, it's a decrease, then infinity to 0, yes, it is a decreasing, then 0 to infinity, 0 to minus infinity, so it is here it is increasing, I guess. No, it is a decreasing, minus infinity to 0, then it will increase. Now sec what is it doing? Sec is saying I first of all in first quadrant I will increase from 1 to infinity, from 1 to infinity, but in second quadrant I will increase from negative infinity to minus 1 in second quadrant. In third quadrant it decrease, in third quadrant it decrease from minus 1 till the minus infinity, so it is increasing. If we had minus infinity to minus 1, then it is what, in decreasing, but here now we have minus 1 to minus infinity, it means this is a decrease. Now next quadrant it is also decreasing, infinity to 1, infinity to, yes, infinity to 1, this side infinity and this one, so of course it is a decrease. Cosec x decrease, increase, decrease, infinity to 1, 1 to infinity, minus infinity to minus 1, and then minus 1 to infinity. What is happening here? Sec and cosec, it is taking from 1 to infinity, and here infinity to 1, but what about here 0 to infinity and infinity to 0, and in this 1 to 0, 0 to 1, 0 to 1, but in this fourth trigonometric functions are getting infinity also, but difference is that it starts from 0 to infinity, but this starts from 0 to infinity, 1 to infinity, not 0 to infinity. Clear? I hope you are clear. Now next we have question. Periodic function. A function f x relates to y is said to be periodic function provided there exists a positive real number t such that f x plus t and fx for all x belongs to x. The number t is said to be the number t is said to be period of the function f. For example, sin x period 2 pi, tan x period pi. Even I didn't understand. This is a periodic function. Here it is a graph of trigonometric function. Let's visualize it. Here what is happening? Here x we have x how much? Minus 4 pi. It is telling you that from here to till here this is in first quadrant. No, don't know. It is saying that here 2 pi is where this is a 2 pi. It is from here to till here this is 180 degree. From here to till here this is a 180 degree, 360 degree. Then here 100. Then this is a y is equal to sin x. Y is equal to sin x. This is y and this is sin. So sin here y is 1. Y is 1. So of course if you put sin x, so sin x, let's say 45, not 45, 1 for 1, so 90. Sin 90 would give us 1. 90. This y is over here, and what is happening here over here? Y is equal to cos x. In this case, what is happening? It is starting from 0. It is starting from 0, and here sin 90 here 1. So sin x, sin y is 1, then sin it would be sin 90. But here this is here over here between 5/2 and 2 pi, between this. So here x x is 0. X is 0. When we will put here 0, then it will give us 0 also. But it is not 0 here. This is not 0. Here we can see y is, we are getting y how much? 0. So we know that sin 180 is 0. That is what we are observing here. Here we are observing that here, this here, intersection. Here we know that this y is 0. If y is 0, so what would be theta for sin? So here it would be 360. We know that sin 360 is 0. We know. Same here, this intersection. It is y is 0 here. So for y, and here we know that 2, then it is add, hold on, 2 pi, then 1 more pi. So of course 180. That's why this is sin x, sin 180 is coming how much? Yeah. Did you visualize it? It is telling you that here you are taking y is 0. So we know that if y is 0, so of course sin 0 degree is 0. We are saying if here we have y is how much? 1. y is 1. So of course we know that sine this much theta will give us 1. So 90. Pi upon 2 is what? 90. 180 by 2. Now here this pi is here. It is telling you that x is a pi, which is a degree, and y is a number, centimeter. So here y is a 0 and x is a pi. When we put x as an input, then we will get output as 0. So we know that sine 180 will give us 0. Same here. It is telling you that x is 2 pi. This is input. When we will enter this input, then we will get what? Output. Y is known as output. X is known as input. So here we are entering input, which is 2 pi. So sine x will give us what? This is a 360 degree. So sine 360 degree is how much? 0 degree. Same here. This is a 2 pi plus 1 pi more. 180 degree. It means 180 degree. So sine 180 degree is a 0. Same here. This is 4 pi. 2 revolution. So sine 2 revolution is what? 0. Only 0. So this was graph of sine x function. Graph of sine x. Here what is happening? Y is equal to cos A. Carefully try to understand. This is very necessary to you for this lecture. It is telling you if we enter input as a x, then we will get automatically what? Output as a y. For example, here we have x. X is how much? 1. Here x not 1. This is 0. It is a y. Okay, so x here we have 0. When we will enter here 0 as an input, then we know that cos 0, all these are degrees. All these are in radians. So cos 0 degree will give us how much? 1. We know that. Now we know that. So here this over here it is we are at how much? And this is pi upon 2. So here we are saying cos 90. So cos 90 will give us how much? 1. No. 0. 0. But hold on, carefully try to understand. Here this is pi upon 2, and this is pi, then 2 pi, then 2 pi. Here x is how much? So y would be 0. Yes, if we are entering this, so it is giving 0. If we enter this pi, then it will give us how much? 100. So here pi is 180, and this is okay, 180. So again it is giving us 0. Y as a 0. But not 0. Here we are getting how much? -1. And this, if we are entering this 2 pi, then we are getting +1. Here same here, 3 pi, then we are getting -1. Here we are saying if when you will put this as a input in function, then you will get a y, which will be -1. So this was graph of cos x. Now next we have tan x. Let's visualize it. Graph of a trigonometric functions. Here what is happening? 0 is where? This is 0, not 0. Pi upon 2, this is 0, this. Here what is happening? If we enter this 0, tan 0, suppose it will give us infinity. It will give us infinity. Y is what? Infinity. Tan at 0 is what? Y is 0. And just opposite, it will be what? Infinity. If we will enter x as a 0, then it is going to be infinity. Now over here, x as a 180 degree, 180 degree, then again y will be infinity, but here this is a minus, negative infinity. Same here, it will keep going on. Okay, this was why this is equal to tan x. Now here what about cot x? This is just opposite of a tan x. Here you can see it is starting from infinity to till this, then again it is going 0 to infinity, negative infinity. At this much degree, cot 0 is what? Infinity, but cot minus 90, it will give us 0. Do you want to see? So remember here cot minus 90, this 90 will give us how much? It will give us y infinity, and this is what is a real number, as we know. And here we have y is equal to cosec x. What is happening over here? It starts from 1, not 1, from minus 2, from 1, I think so, from 1. It is starting from 1. What is happening over here? As we know that cosec x takes also infinity, and it starts from minus 1 or 1 or 1. Here what is happening over here? Cosec 0 is what? Infinity, but cosec 90 is what? 1. Then again 180, this is a infinity. Now it is a minus 1. Now over here is a infinity, minus infinity. Are you visualizing? Here this much minus 90, it is at minus 1, but minus 180, it is the y is infinity. 0, it is a minus infinity. Same here 0, either this side it is what? Minus, this is a positive infinity. But minus 90, this at 90, this is what? This is 1. Y is a 1. Y is coming 1 as a output. Now next we have sec x. Okay, sec x. Here you can see when we are entering x as a 0, then we are getting 1. That means it is starting from 1, but at 90 it is infinity, at 90. But at 180, this is a minus 1, y is a minus 1. And here at 270 degree it is a infinity in both sides, but at 360 it is starting from 1, as you can see. This is what is a graph of a trigonometric sin x function. I can confidently say that yes, I understood all this graphs carefully, logically. Do you know that when we will put this, so this will be known as what? Input. So first of all, you will have to enter here. Whatever you will put here, for example, you are putting here this pi. So you know that this is 180 degree. So here this we have entered x. Now we have to find what is coming y as a output. So we know that at x this y will be 0, this y will be 0, and y is what? Output. Now I am going to move trigonometric functions for sum and difference of two angles. For example, a plus b, this is a two angle. We are taking a as angle, b as angle of other function. Learning objective: functions for sum of two angles, then function of for difference of two angles, then some important identities. Wow! Now we have started with the sum of two angles. We are starting with this. Just have a look at let me drink water. Yeah. This is a sum of two angles, x plus y. Now here we are saying sum of this angle and this angle of this function is what? This cosec x cos y. How did it come? I don't know. Even I don't know. I know that this is a formula for calculating. I know. Later I will discuss about how did it come. Later I will discuss. Right now, whatever is it giving you? Let's understand all this. It is saying that cos the sum of this angle will be this cos x cos y minus sin x sin y. Okay, then same here. Sum of two angles of a sine function will be equal to this. The next, if none of the angles x and y and x plus y is an odd multiple of pi upon 2, then 10x plus y will give us 10x plus 10y, then upon 1 minus 10x into 10y. If none of the angles this and this x comma y and x plus y is an odd multiple of this, then this would be this will come. If none of the angles x and y is a multiple of pi, then this formula you will have to apply pi. So it is at perpendicular, this is a straight line. For perpendicular, you will use this. For straight, you just use this. Okay. Find the value of this sin 45. We know that this is not exact 90, 60, 45, not even 100. But we can say sum of this would give us how much? For example, can we say 60 plus 15? Is it giving us 75? Yes. So 16 plus 60 plus 15. We can write this can be written as a sine, then 60 plus 15. Both are same. Both are same. Now, if in that case you can use sine a plus b. This you can use so that you can easily find the value of sine this much degree. So here we used uh, identities. We know that here first of all we are multiplying this by this, then reciprocal of this is what? Cos. Then we have addition, so sine 30 cos 45 and plus cos 30 then sine 45. Whatever we know here, not both should be unique, that we know. So 30 plus 45 we know. Okay, so this is equal to 1 no 1 by 2, I think so. That is 1 upon root 2. Same here, not root 3 upon 2 here, and this would be 1 upon root 2. Yes, now it is telling you that sine of this degree is this much. After simplifying it, you can get a number, a exact number. It can be in decimal. Now answer is saying that value of this is this much. We used here what? This is a formula because it is giving us, this is giving you option, that's why. Okay? That is how you can find values of any degree of any function. Next question we have, find the value of a cot 75. Same, just function is a function is a other. Okay, here 75, so 45 plus 30. Yes, yes, then here cot, it is coming cot. This is function is a cot. In that case, you know that which trigonometric identity should we use. So here we will use this. It looks like complicated, but after practice it will be easy for you. Just to substitute the value of this degree, cot 45 as we know, 1 cot 30. Do you know? It should be root 3 or 1 upon root 3. Here root 3 minus 1. Yes. After rationalization, we are getting this one, 2 minus root 3. This is the value of this. This is value of this. Okay, are you crystal clear? For cot we use this identities. Okay, you know. What is happening over here? Yeah, this is with a plus and this is with a minus. Next question we have is that this plus this. Here we can use two identities of a trigonometry. First for this, so here 90 plus 15. 90 plus 15. But no. 16 plus 45. Yes, it will work. 60 plus 45. Now next this, for this 40 plus 35. 40 plus 35. Here we will use trigonometry of sine a plus b, because here we are adding angles. Whenever we will be subtracting, then there are other trigonometric identities for different. But here we are adding. For this we can use this sine a plus b, like that trigonometric identities. We know that sine a cos a, then plus cos b sine a. Sine B, sine B. Now let's solve it together. Yeah, 4 sine. Mm, mm, 4 sine. We have used here in both. After simplifying, after substituting in this, we are getting this much. Then after simplifying this, we will get value of this. We got this much. It is equal to this much. Functions for difference of two angles. Now, when we will be subtracting one angles from one angles, then this type of a trigonometric identity we will use. Here cos x minus. Here what are we doing? We are subtracting this from this. So for this we have this. Okay, this is a trigonometric identity. Same with this sine. Tan. For tan, this just operators are changing. It's for cot. Now here find the value of tan 15. 15. So suppose here what will we do? 60 minus no. I think 45 minus 60. Yeah. 60 minus 45 is giving 15. Is giving 15. So here we are subtracting. In that case, we will use. Do you know which identity? Yeah, you know. This no. This 45 minus 30 is giving. Can we not say that 60 minus 30? No. 60 minus 45. Here, after using this trigonometric identity, just substitute the value of this function. Then simplify it. You will get value of this much. Now next find the value of this cos 15. Again 45 minus 30 you can write like that. Otherwise you can write it as 60 minus 45. 40 minus. Here we used what? Trigonometric identity. Then after substituting you are simplifying it. Then you got this much. Value of this is equal to this. It is coming. This is very simple. Just you will have to understand how does trigonometric identity work. How do trigonometric identities work? That is what you will have to understand. Then your question will be easy for you. Ready for challenge. So that tan x, tan 3x, then tan into times tan 2x, then again into tan x is equal to this much. Here we have to prove that LHS is equal to RHS. This is what we have to prove in this. Let's see what will happen. 2x is equal to 3 minus x. 3x minus 1x. Here we are saying, if we here put, we are saying this is equal to this much. It means you want to put this here. This here. Therefore tan 2x is this much. No problem. Whatever you want to, you can do. Just simplify this. Here after using this identity, just to simplify this. You will be able to prove like that. Here you are saying this is equal to this. Some important identities is what this. It will not change its sign, but cos will change its sign. Okay. Here you can see it is at a straight, but when it will come to at a perpendicular, then sine will be as it. But When state will come, then sign will change itself. Here, this is 2 pi, but it's not changing itself. 2 pi minus x. Sine pi upon, it is a perpendicular, so it is also as it. Now it's changing itself. These are some important identities. Here we are observing just uh, a pairing of sines, and this is pairing of sines. Sine. Here you can see. If we are adding any angle with this 90 with 80, then in that case we will change the sign. For example, here this pi, here we are getting sine cos, sine cos, sine cos, sine cos. Sine cos, cosine, sine cos. It is in first quadrant, it is at 0. In that case, and this is at 90 degree perpendicular, and then 3 pi upon, what's happening? It is as it, and it changed. This is a question for you. Functions of a multiple of angles. Function for 2x, function for 3x, let's say function for 2x. Cos 2x is equal to cos square x. Okay. This is equal to this is equal to this is equal to this is equal to this. We know that, yeah. There are a lot of equations. There are a lot of questions. How? A lot of. I can't say. There are also theorems. That's all in this. All this that I skipped, I will be telling you about all about this by doing practice, by solving. All this I will tell you by solving all these questions. It is not possible to explain all this question without practice. Right. So with practice, it will be best to explain all these questions, all concepts that we left. So till here, that's all.